Hello students, my name is Brian, and today we're going to be talking about a little bit of math. You may notice that my name is ASMR Physics Whisperer, but to talk about physics, math is a language that you have to have some basic understanding of before you dive in. I'm not going to take this into a channel that does all these different integrals and derivations to bore you out of your mind. That is not the goal of these videos. The goals of these videos is to show you something interesting. And for those of you who've seen this material before, I want you to be able to look at my videos and say, wow, that guy explained something in a way that my professor never did. I've been learning and teaching physics for quite some time now. I love it with the kind of passion that doesn't really fade with time. And even though my career has taken me away from physics, I've always taught it since I started learning it, and I still teach it today. So let's begin. When we talk about physics and the mathematics involved, a natural question is, where do you start? And the place in which we almost always start is with a coordinate system. A coordinate system is a mathematical construction that is really quite simple at its core. The coordinate system you're all almost certainly familiar with is the XY plane. These numbers, x and y, can be attributed to points that are structured into ordered pairs like this. I imagine most of you have seen this before. And interestingly enough, had you just taken algebra when you learned this, you would almost certainly have all the knowledge you need to really describe what a coordinate system is. So, let's take it a step further. Let's ask ourselves how we generalize this. Well, in order to do that, we need to understand what a field is. Note, this is a mathematical field, not a physics field for those of you who are familiar with vector fields. A field in mathematics is a sophisticated, I wouldn't say complicated, but it's a sophisticated idea. And I'm not going to bore you with the details. Instead, I'll just give you a couple of examples. Or rather, one example. The real numbers are a field in mathematics. They obey certain properties, and they are incredibly useful both in analysis and, of course, in all of physics. So, how would I describe a real number, maybe? It's a question worth asking. How do I describe a real number generally? While this isn't entirely correct for all intents and purposes for physics, any length is an adequate description. They tell you in a maths class that that is not the correct answer, and they are correct, but it is good enough for us, and that is a trend you'll often see in physics, is that things are often good enough because they have to be. So now we have this concept of a field. Well, what do we do with it? This doesn't probably speak to you about how to create a coordinate system. Well, let's tack on a number to this field. independent of what the field is. And we'll call that a dimension. Ah, now we're getting somewhere. I can choose my dimension to be whatever I want. It can be any cardinal number. And when we look at exactly how to choose our dimensions, as physicists, we're usually dealing between 2 to 4 dimensions for most of the work that we do. Knowing this, I can say that the dimension that we will be dealing with most is 3 dimensions. So, from this, I have chosen my field and my dimensions. So now all I need to do is construct a space in which there are 3 indices that can take on any real numbered value. And that's your coordinate system. For the coordinate system you're likely familiar with, it's 2 dimensions. We have an x direction and a y direction, and there are numbers associated with every point in the space around it. For 3 dimensions, we have a similar extension. We have the xy plane along this surface, and we have a 3rd direction z that goes up. This is a very useful way of looking at space, and it is the basis from which we can then begin to discuss something called a vector. Now, unlike a field, a vector is a very complicated mathematical object. I'm not going to bore you with all the rigor and details of it, though. Those of you who already know it obviously don't need it repeated, and those of you who don't know or need to know it will not find it interesting at all. It's rather dull if you ask me. Instead, what we will simply say is that a vector, which is the second thing we truly need to understand, is going to be a direction associated with an ordered pair. This is a very physics description. Now, I did say ordered pair, but we're dealing with 3 dimensions, so we'll have to call it an ordered triple for now. This is the basic idea of a vector, is that you now have a coordinate system with numbers associated with every point in space, everywhere in space around it. And with each of those points, each of those values, there's an associated direction. Now, that direction is not towards that point. That may be the overall direction of that ordered pair, but the directions associated with each number of the ordered pair are a specific kind of vector called a basis vector. Basis vectors are vectors by which, if you multiply them by a number, the basis vectors together will give you any point in that coordinate system. They will give you any point. So the basis vectors for our xyz plane are often noted as x hat, which equals the vector 1, 0, 0, y hat, which equals 0, 1, 0, and z hat, which equals 0, 0, 1. Now, as we look at these, you may ask, well, what are these brackets? What are these numbers? Why are your ordered triples structured in this way? I would say don't sweat it too much. If you don't already know, it won't be terribly important for what comes next. Just wait for it. Now, all this says is that my direction for x is 1 along the x-axis. My direction for y hat is 1 along the y-axis. And my direction for z is 1 along the z-axis. Now, that is an important thing to note, is that they're all of unit length. They all have 1 as their magnitude. And that is true of any basis vector. Every basis vector in existence has to be of unit length. The reason is that, let's say I want to multiply something by it. If it's of unit length, that is extremely convenient because it will not change the magnitude of the number you multiplied it by. That means if I have something like, say, 9x hat, the x hat dictates the direction, but it does not dictate the magnitude. If I were to, say, choose a vector for my basis vector that isn't of unit length, this whole thing would fall apart and it would be illogical nonsense. These are the basic objects and systems by which we operate in physics. But there are some things that we should note first, and before we move on to actual physics. Second, rather. And we will talk about those in my next video, which I will upload tomorrow at around 6 p.m. Thank you all for watching. I hope you get some good rest, or you've maybe learned a thing or two while you watch this. I know most of you probably don't know what a field is. And if you're curious about any of these things, please ask me in the comments. I can go into some detail. I'm not going to go into a paper writing frenzy in the comment section, but I will do my best. Again, thank you so much for watching. I hope you all have a wonderful evening, morning, afternoon, what have you. Take care.